Hello, this is Renee Robinson. I'm going to be going over some basic stoichiometry problems. In this first video, I'm going to go over mole-to-mole problems using stoichiometry. With the problem that you see in front of you, I have pulled off of the Modern Chemistry book that you see in the top left-hand corner, number 1A on page 287. The problem reads as follows. Balance the following equation. Then, based on the amount in moles of each reactant or product given, determine the corresponding amount in moles of each of the other reactants and products involved in the reaction. So here I see that we have ammonia and oxygen reacting to produce nitrogen and water. To balance this reaction, I first need to see that I have only 2 ammonia on this side, or 2 nitrogen on this side, or 1 nitrogen on this side and 2 on this side that need to be balanced. I can see that my oxygens are unbalanced and my hydrogens are unbalanced. Now, when you're balancing equations, it's all about just trying to plug in numbers. I've already balanced this one, and I know that the coefficient in front of ammonia should be 4. The coefficient in front of oxygen should be 3. Coefficient in front of nitrogen should be 2, and coefficient in front of water should be 6. All right, with mole-to-mole problems, they're always going to give you an amount in moles of one of the formulas in your equation. So in this one, they gave me 4 moles of ammonia, and they're asking me to find moles of any of the other reactants or products. So I'm trying to find moles of oxygen, moles of nitrogen, and moles of water. With any stoichiometry problem, first thing is always to balance. Second, you're always going to write out what you're given and what you're trying to find. In this one, the given's already here, is what is given to me. And I'm trying to find moles of what I've circled and boxed over here. So you're always going to start off with what's given to you. In this one, 4 moles of ammonia, NH3. I like train tracks, so I'm going to do my little train tracks. To cancel moles of ammonia, you need to put moles of ammonia down here. And then we'll go ahead and start with oxygen at first. So we're going to find moles of oxygen. All right, when we do these mole to mole, we're always pulling from the balanced chemical equation. So for ammonia, we can see that we have 4 moles of ammonia for every 3 moles of oxygen. So if you do that math, we should find 4 times 3, which would be around, 12, divided by 4, you should get 3 moles of oxygen. Just that simple. All right, let's go on to, we've done our oxygen, we'll go on to nitrogen. Same thing, always start off with what's given to you, 4 moles of ammonia. Do my little train tracks. I need to cancel moles of ammonia, so I'm going to put that down here. And then now we'll do moles of nitrogen, since that's the next chemical in the equation. All right, and we always pull from the balanced chemical equation. So again, we have 4 moles of ammonia, and this time we have 2 moles of nitrogen. So if we do this one, we multiply 4 times 2, divided by 4, that would be 8, divided by 4, so we should get 2 moles of nitrogen. All right, let's move on. Last one. Again, always start with what's given in the top left-hand corner. Cancel our moles of ammonia, so we need to put that down here at the bottom. And then this time we'll find moles of water. All right, again, pull from the balanced chemical equation, and we've been using moles of ammonia this whole time, so I added 4. And then oxygen, we have 6 moles of, water, we have 6 moles of water. And if we do this calculation, 4 times 6 divided by 4, we should get 6 moles of water. All right, and just to refresh, this mole to mole that we're seeing in this step, basically this whole step, is what we call our mole ratio. This one we are relating our moles of one of the products or reactants to the moles of another product or reactant. And that you're going to see in every single stoichiometry problem. And I like to call it the transition step, because you are transitioning from the compound that was given to you to the compound that you're trying to find. Compound that was given to you to the compound that you're trying to find. Compound given to you to the compound that you're trying to find. And you'll see that in every single stoichiometry problem. All right, hope you learned something about mole to mole stoichiometry problems. Thank you.